Okay, so I'm going to show you how to compare or calculate first the equivalent annual cost for machines. So the equivalent annual cost is basically a method used to compare two different investments with different lifespans, uh, their cost per year essentially. So I'm going to start off with machine A. So this one costs 510 grand, lasts for 4 years, 78 grand a year, rises at 4% because of inflation. And then as well as that, is 20% reducing balance, and then 30% tax and discount rate of 10%. So first we need to discount it essentially. Oh, sorry, we need to depreciate it per year on a reducing balance. So the original tax written down value, so it's 510k in the first year, and then we're going to depreciate it by 20%, which is 102 grand first year. And then in the second year, 81. And I'm just going to keep doing this essentially. Shield, so we're going to multiply each of these by 0.3. Great. And now we are going to calculate the OPEX after tax each year. So in the first year, we know it's 78 grand and it rises at 4%. So you have 78,000, and then multiply each of these by 1.04. So we have 81,120 in the second year. And then we're going to multiply this by 1 minus 0.3. So basically 0.7 each year to get the after-tax operating cost. Now we want to find the net cost per year. And so what this is you do the OPEX after tax minus the tax shield. So now after we've done that, we've subtracted the tax shield, and then this is the net cost here. Now what we're going to do is we want to discount these to the present day, and remember our rate is 10%. So after this, you have the net cost here, so 24 grand, and you multiply by the discount factors. So this is so if you do that, you have the original cost, the 510 grand plus 109,389, which is just all of these added up. And if you add those together, you get the net present value, which is £619,000, 389 pounds, 0.72p. And obviously it depends on your rounding. Like I'm just being a bit specific, but as long as it's in that range, you be correct. And now what you need to do is you need to find the annuity factor to divide this by. And this essentially allows us to get the equivalent annual cost. So that's going to be 1 minus 1 divided by 1 plus 0.1 to 4, because 4 years over 0.1. We have to take the £619,389, divide that by 3.17 pounds per year, roughly. And now what we need to do is we need to do the exact same thing, but for machine B. So I'll do that in red. So machine B is 760K, 5 years, operating cost 52 grand, and its inflation rate is 6% a year instead of 4%. So based on this, machine B's equivalent annual cost is 209,772. Note here that the annuity factor is different because if we look back at the formula, the only thing that would change, the only thing that would change would be the 4 would be a 5, so you get 3.8 instead of 3.17, which gives you £209,772. So in this case, the company would choose machine A because the equivalent annual cost for this is 195,390, so it's cheaper to do machine A every year. So yeah, the maths in this kind of question is quite straightforward. It's more just remembering the steps and making sure you follow